This is part 2 of chapter 4, correlation and prediction. In the first video, we talked a lot about Pearson correlations. We're just briefly going to talk about some additional correlation coefficients. The most common secondary is what we call our Spearman's rank correlation coefficient. For Spearman's correlations, data is based on an ordinal scale instead of a continuous scale. If we remember from previous chapters, ordinal data is data that occurs in an order, like places in a race, but the numbers are arbitrary, versus a continuous scale, think of it of occurring on a number line, such as height or weight occurs on a continuous scale. So we can use Spearman correlation coefficients when we're analyzing ordinal data. While we talked about R for Pearson correlations, Spearman's correlations use this symbol, and it's read as rho. This link allows you to practice predicting the different correlations, whether it's positive and negative or the strength of the correlation. I would really recommend doing some practices so that you can interpret this data visually on an exam. Next, we're going to talk about prediction. So there's different statistical analysis that we can do so that we can try to predict or estimate one variable, aka y, from another variable, or x. If we're looking at how one y predicts one x, it's a simple correlation. If we want to see how one y predicts multiple x's, it's a multiple correlation. If x and y are highly related, then x can predict y to some degree, and y can predict x to some degree. Just because these can be predicted does not imply cause and effect. It never implies cause and effect. It's always just predicted and relationships. Here is a plot of a straight line. This is figure 4.9 in your textbook. As you can see, the line perfectly passes through our data points. That would be the ultimate goal. That line is called a regression line, or a line of best fit. In most data sets, that line will not pass through all of the data points exactly, but we use calculations in order to estimate the line that comes closest to the majority of the data points. So simple linear prediction is also called regression. Regression is a statistical method that's used to predict the criterion, outcome, or the dependent variable, also known as y, from a single predictor, also known as x, or our independent variable. This prediction equation shares the same form as the equation for a straight line in plane geometry. We're not going to talk a ton about regression, but just know that it's a statistical method where our dependent variable is trying to predict our independent variable. Just like with our correlation data previously, we can get errors in our prediction. Remember, with our correlation coefficients, a perfect correlation was either a positive one or a negative one. Unless that correlation coefficient is exactly -1 or +1, there's going to be some sort of error or variability. That next symbol, y with the little triangle on top, is known as y hat. And so your y hat will not necessarily be equal to your y unless your correlation coefficient is -1 or +1. So in order to calculate our error, or our E, we take our y minus our y hat. Our y is what we got, and our y hat is what was expected, okay? So when we're looking at that line, it's what we in relation to the data point, it's what that data point was compared to what we expected it to be, where we expected it to fall on the line. That error represents the inaccuracy of our prediction of y based on the prediction equation that we use. So here's a visual representation of the error that we were talking about on the previous slide. This is figure 4.10 in your book. So if we first look at this red box, this data point is what the subject actually got. So we're looking at pull-up scores. So they were able to do 12 pull-ups, and their weight, which is on the x-axis, they weigh 140 pounds, okay? So this blue dot is their predicted score. So we predicted that at 140 pounds, they would do 7.97 pull-ups specifically. So when we're calculating the error score, we're calculating the difference between those 2 points. So if we look at the equation here, our error score is what they actually got, which is 12, subtracted by what we expected them to get, where we expected that point to hit on the line, which was 7.97, to get an error score of 4.03. So while there's error in every statistical analysis, we can calculate a standard error of estimate. This is sometimes referred to as the SEE or the standard error, so it's just abbreviated as SE, or standard error of prediction, or SEP. So it comes by a lot of names, but what it means is that the statistic that reflects the average amount of error in the process of predicting Y from S. So we're looking at that average error across all of those data points on the previous graph that we looked at. What is that average error of predicting Y from X? So our equation is our SE, or standard error, equals SY. So SY is the standard deviation of Y scores. So that SY multiplied by the square root of 1 minus our R squared. So remember we talked about R squared previously when we were talking about correlation coefficients. I'm not going to make you calculate standard errors by hand, but it's something that I want you to be familiar with in terms of concepts. Lastly, we're going to talk a little bit about multiple regression. So multiple regression is a much more complex prediction of Y that can be developed with the use of more than one predictor. So it's using multiple X's to predict Y. So we could look at pull-ups and chin-ups to try to predict weight, is one example. This is used in much higher level statistical analysis. Again, it's not something that we're going to be calculating by hand in this class, but it is a common statistical technique that is used in different exercise fields. In summary, correlation and prediction statistics are that foundation and provide a lot of the necessary skills for measurement and evaluations. We have to understand how to interpret that data to make it meaningful for us. These skills are necessary to generate measurement theory, as well as applying reliability and validity concepts to different problems. So while statistics is not everybody's cup of tea, we do need to understand this foundation in order to evaluate our different measurement and evaluation tests. The following slides are some additional review questions that, again, I would highly recommend going through and knowing the answers for before you take your module quiz.